So, good evening, everyone. My name is Rebecca Tierney. Most of you hopefully know me at this stage. I'm the poultry advisor with Teagasc. Um, I'm delighted to be joined by our guest this evening, Tom Willings, Director of Strategy and Partnerships with EggBase, based in the UK. We also then have my own colleagues, Jonathan Herron and Linda Omodara. Jonathan looks after the AgNav for Teagasc, while Linda is developing the poultry and pig side of AgNav for us, which is great news. And we also are delighted to be joined by Brendan Soden, the recently elected IFA poultry chairman, who also most of you will know. And if you don't, you'll certainly get to know him over the next couple of years, I'm sure. But a wealth of knowledge. So look, we'll not delay. I'll get Jonathan and Linda to maybe share their screen and get us started. Just to point out that there is a question and answer tab at the bottom of your screen, whether you're working off a mobile phone or a tablet or a laptop. Please do pop in any questions you have and we'll put them to Jonathan, Linda, and Tom at the end. This is a great opportunity to clear up maybe any fears or concerns that might be around what data can be given for this type of a data collection process and what you need to be aware of for your carbon footprint and just how important it is. So if you guys are ready, Jonathan and Linda, I'll mute myself and leave the talking to you guys for the next couple of minutes. Thank you.
Yeah, so thank you very much for Rebecca for inviting us to the webinar, and I hope that, as you said, that'll be informative for the people who have joined us this evening. So yes, my name is Jonathan Hearn. I'm a research officer in Teagasc, and we're also joined here by Linda Omodara, who's also a research officer in Teagasc, who specifically is focusing on poultry and pigs, as Rebecca said. So we've been invited to ask around carbon footprints of poultry systems. What is it and why do we calculate? Okay, so we'll move on to the next slide. Thank you. So we're going to cover what carbon footprint is, why they're important, and then we're also going to introduce you to the tool that's been developed in Ireland called AgNav and what stage it is at, particularly for the poultry sectors. So I'm going to whistle, it's going to be a whistle stop tour, but I think it's important to give a little bit of context. So greenhouse gases, it's a natural, and the greenhouse gas effect is a natural occurring phenomenon. Without greenhouse gases in the atmosphere, the temperature of the Earth, it wouldn't be habitable for humans to live in it. It'd be too cold, it'd be minus 15 degrees. So without greenhouse gases in the atmosphere, it essentially works like a layer of insulation that's surrounding our planet. Now, the natural greenhouse gas effect is not what we hear in the news or in any publications or anything like that. What they are referring to is called the human enhanced greenhouse gas effect. And that essentially is the contribution to human activities that's increasing the concentration of greenhouse gases in the atmosphere, which is essentially thickening that layer of insulation. So of the energy that comes in from the sun, less of that is being lost back out to the space, and more of it's being retained, and thus it's increasing the global temperature at a rate that's greater than the natural effect. So that's what's the real concern is when you hear anything in the media around greenhouse gases. Okay, Linda? Keep going if you fill out the slide, yeah. So the main greenhouse gases that we talk about, it's specifically for agriculture, it's your carbon dioxide, so your CO2, your methane, and nitrous oxide. They're the main three ones. Now, every gas is different, in their ability to take in energy as well as how long it lasts in the atmosphere before it breaks down. So what has been developed for policy, but also for ease of reporting, is bringing all greenhouse gases to a common unit. So that's done by using this global warming potential. And essentially what it does is it brings a greenhouse gas and the warming caused by that greenhouse gas back to a reference, okay? The reference being carbon dioxide. So whenever you hear of a carbon dioxide equivalent or carbon footprints, it's not just carbon dioxide, it includes carbon dioxide, methane, nitrous oxide, as well as others. Essentially what that means is that for every 1 kilo of methane, as in that table up on the right, that's the equivalent of 27 kilos of carbon dioxide. 1 kilo nitrous oxide is the equivalent of 273 kilos of carbon dioxide. So they're just a bit more potent than the CO2. Okay, next slide. Okay, so where are we at in Ireland? Okay, and Ireland is in a very particular place compared to other countries in that our ag sector is the main contributor to our national greenhouse gas emissions. So approximately 38% comes from the agricultural sector. If you go to the continent, you're looking at the 10-12% mark. And it's a reflection of the type of economy in which we have, but it's also a reflection of the agricultural systems in which we have and how we manage our land, which is predominantly dealing with ruminant production systems. So that green bar there is essentially that's coming from your the methane from ruminants. So with the focus on greenhouse on climate change and looking at national greenhouse gas emissions, the government have established a climate action plan where we have to reduce our greenhouse gas emissions by 25% by 2030. Okay. In recent years, we are going in the right direction. So why should we really care about this? Okay, so there's a number of different angles on this and why we need to take this into consideration. So first of all, the definition in terms of carbon footprint would be it's the greenhouse gas emissions per unit product. So how much gases were emitted to produce that kilo of eggs, kilo of live weight in terms of broiler. And anything that you express per unit product is efficiency. Okay, and so essentially what it means is you're reducing the inputs per kilo that you are producing, and that's also directly linked to profitability. Okay, so efficiency and carbon footprint and economic performance, they are linked with one another. Carbon footprints can be used to try to identify inefficiencies in your system. Poultry systems, it's been well reported, they are significantly lower in terms of the greenhouse gas emissions and their carbon footprint compared to your ruminant products. But there is significant levels of production, so even small efficiency gains can have a significant effect. The other thing as well is, and what is done largely in the ruminant sector, is the marketability of products coming from these systems. So if a sector is able to demonstrate that their greenhouse gas emissions are low and they're going in the right direction, that also helps in terms of entering higher value markets and also addresses consumers are becoming increasingly concerned around how food is produced. And then lastly, it also aligns with industry reporting requirements. So there's an increasing ask from companies to report their environmental, social, and governance data, and greenhouse gas emissions is one of those. Okay. So how do we calculate greenhouse gas emissions? Okay, so it's not possible to go around to every single farm and measure every single source. It's just not feasible, not costly, or makes sense. So what we do is we use mathematical models based on relationships in which we have determined by doing trials. And what we do is we calculate greenhouse gas emissions based off that. Now, there's two different levels, okay, and how emissions are calculated. In the middle, you have inventory. So they're the emissions that happen within the jurisdiction of Ireland, so within the borders of Ireland, and they're the ones that get captured at our national greenhouse gas emissions level. So the government only cares about those that happen within the borders of Ireland. Now, when it comes to actually seeing the full picture of what goes into producing a product, you need to account for what is imported into the country, such as feed, such as fuel or electricity, as well as fertilizers. So to get a more rounded picture, a fuller picture of what goes into producing that 1 kilo product, we use a method called life cycle assessment. And that's the method that's used for your carbon footprint. Okay. So just an introduction into AgNav. So what is AgNav? It's an online tool that has been developed the last number of years. It's a partnership between Teagasc, Board BIA, and ICBF. Can you hear me?
Yeah, we can hear you okay, Jonathan?
Yeah, sorry, my screen just went. Apologies. I'm back. Yeah, cool. Yeah, so AgNav, what it is, a partnership between Teagasc, ICBF, so Irish Cattle Breeding Federation, and Board BIA. It's an online tool that provides farmers with key informations around environmental indicators, but as well as productivity indicators. And what the whole objective is to provide one platform for the sector. So it's one number across whether it's processors, consumers, or the farmers. It's the same number. So there's consistency in it. Okay, and the key thing to it is using available data where possible. So what does everybody do? So Teagasc, it brings the research and it brings the advisory. That's our bread and butter. ICBF is more, I suppose, it is based on cattle because that's what we started with, but it allows us to centralize data into one place and makes life a lot easier for everybody, reducing the amount of questions being asked from farmers. And then lastly, it's the board BIA. So that's they bring in scope and scale in terms of their board BIA quality assurance schemes as well as the marketing of that final product, which can help us achieve those prices. Okay. So that's the key benefits is, so it started with dairy and beef. There was a request from those sectors at the time to provide such information to assist advisory and farmers. We maximize the use of existing databases where possible to streamline the data collection process and improve accuracy of calculations. All the methodologies have scientific oversight and they are independently reviewed. It ensures there's no duplication, so one number for one farm, so there's not multiple numbers for a farm. And AgNav is freely available for farmers through the Teagasc advisory services. Okay. Can you move, Linda?
Yeah. Okay.
Okay, cool. So there's 3 different ways that we're accessing at the moment. So it's through the Signpost Advisory Program, through sustainability programs within processors, and farmers themselves at the moment can go on if they want to see where their numbers are at and self-register. Okay. So this is just a screenshot of examples of what is provided. So what we do in AgNav, we can calculate the emissions of the total farm, the emissions per hectare, and the emissions per product. Okay. We also look at other things such as ammonia, nutrient balances, as well as soil carbon. Okay. What we also provide within the tool, so once you establish your baseline and you know where you're starting, we then have this look-see function. So provides the mitigation measures or any actions that could impact greenhouse gas emissions, and you can test out what impact that may have on your farm. So it may make sense for you, and it may not make sense for another farm. So it helps creating a tailored action plan for that farm. Okay. And then lastly, that's essentially where we arrive at. It's based on that conversation. So with the farmer and advisor that's using the tool, we can then identify what actions are impactful for that farm. So instead of going with this one blueprint for everybody, it's tailored action plans. Okay, Linda. This research is part of a wider project. So as I said, we started with dairy and beef. We're now moving into other enterprises, and this is through a project that has been funded through the Department of Agriculture, Food and Marine. And as you can see there in the middle in task 5, it is focused on monogastrics, which is the poultry and pigs. I suppose this is where I'm going to hand over to Linda, who's going to tell you about the development on the poultry side.
All right, thanks, Jonathan. So for this AgNav research, a poultry model has been developed, and it's been developed for layers, broilers, and pullets. It's currently in piloting stage, so we are currently running the model to see if everything works. And after that, we'll go to the testing stage, whereby we'll gather real farm data to populate the model. So for AgNav Poultry LCA, the goal is to calculate the carbon footprint of poultry systems in Ireland. And the scope is for one production cycle. So for broilers, this could mean up to 65 days, depending on the farm. And then for layers, it could mean up to 90 weeks. So the system's boundary is cradle to farm gate, which could mean from the breeding flocks. So the breeding flock consists of the grandparent and the parents' generation before it comes to the hatchery, and then it goes to the day-old chick. And then the farm gate up is when the egg or the layers, sorry, or the broilers is leaving the farm. Then for the inventory, unlike in the beef and dairy model in AgNav, where there is already existing database that could be used to plug in to the AgNav model. In poultry, we don't have any available. So it is very important for farmers to provide real farm data so we can populate our LCA model. And this farm data that will be provided by the farmers will be known as primary data, also called activity data. So it is with this data we will use to calculate your environmental footprint. So it is extremely crucial for farmers to give primary data as much as possible. So secondary data is mainly for off-farm activities. For example, for crop cultivation, which the farmers have no direct control over, or also for the breeding flock as well. And for our LCA model, we use international standards, IPCC and LEAP to build the model. And so for the carbon footprint, it's measured in total CO2 equivalent per kg of product. And your product could be, in this case, either X for the layer system or live weight for the broiler, for live weight of broiler for the broiler system. And for this diagram, you can see that the first one is showing how the process flows in the AgNav poultry LCA model. So first of all, it starts from the breeding flock, which consists of the grandparent and the parents generation. And from there on, it goes to the hatchery, and then it comes to the day-old chick, which is then raised to pullets, layers, and the final products, which is eggs. Similarly, for the broiler system, it goes from the breeding flock to the hatchery, to the day-old chicks, and also to the broiler rearing, and the final output is the broiler in this case. So for our AgNav poultry model, like I said, it is very important to have primary data for the survey. So we have 3 surveys in for AgNav. It's pullet survey, layer survey, and broiler survey. So I put in only the 2 of them here because the pullet survey is feeding in directly to the layer survey. And so for our farm survey, it's consisted or is classified into 5 groups. So we have the production, which consists of 9 questions. And some of the questions you will see here is about the number of birds, their weight on entering and leaving the farm, also mortality, and also the amount of calls per cycle. Then the feed and water section could be the quantity of feed given to the birds and also the water. Then the housing and manure management consists of 11 questions, and some of the questions include the kind of housing system for the birds, how the manure is stored in the farm, and how frequently the manure is removed from the farm, and the number of and the amount of manure moved out from the farm. Then for the electricity and fuel, so this is for the fuel is mainly about the transportation that is done on farm, and also for heating in the case of broiler rearing and pullet rearing as well. Electricity used on farm is also gathered. And so for the electricity, there are questions about if your farm uses renewable energy, the source of energy, the quantity of energy, and if you sell electricity back to the grid. There are other questions. So these other questions could include questions like kind of disinfectant used, rodenticide used, and also vaccination. And also the same thing for the broiler survey. So it's just a little bit different. So now the systems boundary, like I said before, is cradle to farm gate. So right from the when the crops is being produced and cultivated up to when the in this case when the live weight broiler is leaving the farm gate. So for LCA for our broiler LCA models, it's further divided into 3 submodels for simplicity purposes. So as you can see, there is a feed production submodel, the breeding flock submodel, and broiler production submodel. And each of these submodels have inputs and output flows moving in and out of it. And the carbon footprint, like I said earlier, is kg CO2 equivalent per kg live weight of broilers. So this diagram is showing the inputs and the output flow in our AgNav broiler LCA model. So it begins with the hatching eggs, which moves to the breeding flock. So these hatching eggs will make up the grandparents generation. And then from the grandparents to the parents generation, from then on, it will become a day-old chick. And so it has inputs such as the feed, water, electricity, heating, litter, day-old chick, and housing. And this input is for both breeding flock and broiler rearing. The second input here is for the feed production. So the feed production includes crop production. Crop production includes some processes like the kind of fertilizers used and also pesticides used on farm, not on poultry farm, but where the feed is being cultivated from. So the data for this is gotten from our LCA models. And then it also consists of crop processing, feed processing, and transportation. Then for the third input, it's electricity and fuel. So it consists of how much electricity is used on farm, also for feed processing, for fuel use on and off farm, also for fuel production and transportation. Now for the outputs, the main output for the broiler model is the broiler itself. And then we have waste and emissions. So the waste could include mortality, cows, manure, infertile eggs, which is from the hatching egg, and also feed waste. And then we have 4 major emissions, 3 of them, CO2, methane, and nitrous oxide. They are greenhouse gas emissions, but the last one, ammonia, is not a direct greenhouse emission, but it's an indirect greenhouse emission, and it's a major contributor of nitrous oxide. And on its own, it's a pollutant that can cause health hazard to both human and animals. For example, it causes respiratory problems. Then similarly for the layers LCA, we have the systems boundary also from the cradle to the farm gate. And in this case, the layer LCA submodel is divided into four parts. So we have the feed production, the breeding flock, the pullets, and the egg production. And in this case, the carbon footprint is measured in kg CO2 equivalent per kg of eggs. Also in this model is almost similar to the broiler LCA model, but the only difference is the output, which is the eggs. So it has two outputs. So the primary output, which is the eggs, and the secondary output, which is the spent hen, and also the waste aspect of it as well. So to conclude, there is a need to reduce emissions from live sectors across Ireland. And LCM models have been developed to calculate the carbon footprint. And in Ireland, AgNav platform is being developed to include the poultry systems. And currently, our poultry models are at the stage of piloting, and testing will begin soon. Thank you.
Brilliant. Thank you so much, Linda and Jonathan. A great start to explaining the importance of carbon footprint, and great to see that AgNav is coming along so fast. That's brilliant news. So Tom, I'll ask you to turn on your camera and start sharing. I'll ask everybody that's joined us to continue to send in your questions to the Q&A, and we'll put those to our panelists at the end. So we're just about to see your screen, Tom. You should pop it in slideshow mode, hopefully.
Hopefully that's working.
That's it, Tom. That's it, working perfectly. You're good to go.
Okay.
Brilliant. Thanks, Tom.
Okay. Yeah. Thanks, Rebecca. Good evening, everybody. And yeah, Linda, Jonathan, great presentation. Fantastic way to set the scene and to explain, why we're all having this conversation this evening. This is becoming an ever more important part of business as usual. As you've explained, there's pressures from all sorts of sectors to start to understand more about our impact on the environment. Perhaps you'll be wondering, well, why is EggBase, a corporate business following on from AgNav, a free-to-air system that is in a pilot stage? And perhaps that's the answer, is that we've been operating and conducting product carbon footprints on poultry farms for 6 or 7 years. And so my job now is to just explain some of the practicalities about how data is collected, what information is required, although Linda's just done a brilliant job of explaining some of that. And so I'll whistle stop through that. But then once you've got your report, what does it actually tell you? And what are your options? What are your choices? What are the levers to look at mitigating your emissions? And then finally, I'm going to try and kick off the Q&A with a little bit of a myth busting session. So I've got 4 or 5 questions that I hear all of the time that I thought I would try and address as openly and upfront from the beginning. And and then hopefully inspire you guys to ask your own questions at the end. So on the screen, there's my kind of agenda for the next 20 minutes. Who am I? As Rebecca said, my name is Tom Willings. I'm Director of Strategy and Partnerships at EggBase, but really I'm an egg supply chain guy. I've been 15 years in the industry. I actually work part-time for EggBase, and I don't work part-time as a consultant for a number of other companies. But my background really is in buying eggs from farmers and selling eggs to supermarkets. So I'm not a climate scientist like it sounds as though Jonathan and Linda might be, so you can save the technical questions for those guys. But as what the market wants, what the market needs, and how we're getting there, then I've got some hopefully pretty useful experience to bring to bear. So I look forward to discussing that later. Who are EggBase? Well, we are a cloud-based data company. We've got our roots in UK, but as I'll show you in a minute, our operations are now very much global. More than half of our business is abroad, but our clients number many thousands of poultry sheds in all aspects of poultry production, from the laying sector and all parts of that life cycle, from parent stock and even rearers in advance of being parent stock, through to layers. And the same is true in the broiler industry as well, so broiler breeders and into commercial stock too. As I mentioned, we've got clients all over the world, but not just in primary production. So part of the benefit of being cloud-based is that we kind of cut through all of the borders and the barriers that might result in sort of siloed software platforms only looking at data on premise. We really try and connect everybody using cloud-based technology to allow you to benchmark and analyze irrespective of where you are in the world and where all of your farms might be located. So many of our clients have got farms in more than one country, and our software allows them to look across their entire business at the touch of a button. Our 3 core products are farm data capture through our brand names EggSense and Avisense, the carbon calculator I'm going to talk to you about today, and then a product called EggBase Packer, which is about traceability and visibility of eggs as they move right the way through the supply chain, from really before lay in forecasting right the way through to customer traceability once they've left the packing center. But today, again, it's all about the carbon footprint. As I've mentioned, we've been carbon footprinting for some time, 6 or 7 years or so. So we're definitely not new at this game, but that's not to say not developing, because this science is permanently under review, and we play a very active part in the community of carbon footprinting businesses in the UK and abroad, and with governments as well, to make sure that we are absolutely up to date and on song. And our calculations that we perform for people have been conducted to a methodology that's been rigorously checked by the leading authorities in this space. So the University of Cambridge and their Centre for Industrial Sustainability, their Institute for Manufacturing, to give it its full title, sort of front and centre. But more recently, you'll have heard of the kite mark on British goods, and we've gone through some pretty rigorous testing with the British Standards Institution before achieving their approval for carbon neutral product on supermarket shelves, which you can go and buy today. So without further ado, I'm going to quickly run through and unashamedly touch on many of the points that Linda has just made to do with the information that's required when you're asked, inevitably, to complete a carbon footprint. This word boundary, you're going to hear it all the time, and it is the critical point because it defines exactly the area that people are looking to measure. So that's an area of time and of space. So in our world, we're talking about the life cycle of the bird, and the definition, as Linda has used, of cradle to farm gate. In very simple English, when we look at a diverse farm with all sorts of activities on the go, if we're asking for data relating to, or in order to be able to conduct a footprint for eggs or for poultry meat, what we're asking for is only the data that pertains to that activity of producing the eggs or producing the chicken. We've heard to this evening already enteric emissions, so associated with ruminant livestock, or a lot of soil-based analyses and measurements that each could be relevant to dairy or to arable growing. Poultry being as intensive as it is, and principally indoor, notwithstanding the free range element of the sector, is much more straightforward by way of a calculation and by data in and out. So I think the first thing to say is that this should hold no fear for anybody. If you're asked to conduct a carbon footprint on your poultry shed, very different for dairy or very different for combinable crops, etc. A lot more moving parts. But for poultry, the questions that you should be being asked and the data that's required, I would like to think that the vast majority of farmers have already got a good handle on the information that will be asked of them. And it's data that actually, if you do know and you're able to measure it and you're able to manage it, it's going to help you improve your business even without looking at it from a carbon footprinting perspective. So just to list them out, and these are very similar to Linda's sort of questions by individual category. We've got a slide here for layers and a slide for broilers. But the first information we need to know is, where is your farm based, and an explanation of how you go about producing your eggs, so organic or free range, an indoor system, barn or colony, your manure management protocols, and where the manure ends up is part of that consideration. And then it's the time frame. It's the time frame over which we're going to conduct our measurement. That includes the hatch date of the day-old chick, the date that you receive the birds on your farm, the depletion date, and then the cleaning cycle as well. We need to know as much as we can about the inbound pullet, and its breed, its origin, and its quantity, how it arrived on your farm. Then it's the sort of production stats that are meat and drink for most farmers. So total egg numbers, body weights of the bird, egg weight to help us calculate the egg mass over the entire life cycle of the bird, and mortality information. Exactly as Linda's described, utility and fuel information, and then as much detail as you can give us on the quantity, the origin, and the type of bedding or enrichment. We will ask you for some cost information, and I'm going to come back to that very topic at the end of my slides. But cleaning chemicals and medication, which could be vaccination, it could be wormer or any antibiotics, any nutraceutical stuff that's given to the bird during the cycle. We need to understand the cost of the product of that, making sure that we exclude any of the veterinary time that's being charged, which ultimately is labour. If your birds have got access to the outside, then we want some information around the area of ground that they've got access to and the condition of that pasture. Whether or not they share that pasture with another species, are you taking a crop of silage or any other activity within the range area? And then if you've got tree planting or enrichment on the ground, then as much detail on the species and age of that kind of green capital as well. It's a very similar picture for broilers, and the main differences are around the length of the life cycle and the unit of measure in terms of the production. So we can conduct a footprint on anything from a single crop cycle, it could be 35 days or so, but we can also aggregate a number of crops. And so long as we've got accurate data in terms of total live weight yield, so including data of any thin that might take place, then we can add a number of flocks together and have almost a smoothed result over time. Otherwise, it's a very, very similar set of data. And once again, it's data that I think most poultry businesses have got in spades anyway. The thing I haven't mentioned yet is feed. And feed is by far and away, as I'll show you in a moment when we look to results, the biggest influence and the biggest variable, and often quite difficult information to access. Every farm will know, the life stage nutrition that they've provided to their bird, and probably have a very good handle on exactly how many tons, how many kilograms of each individual ration has been fed to their hens or their broilers over the course of the flock or the crop. They'll also know exactly where they've bought it from and have a good set of records as to how many feed deliveries have been made. That's important, so we can calculate the road miles that have been driven in order to bring that feed to you. Where it gets slightly more complicated is that we need to know more about that feed. We need to understand the raw materials that are in each ration, and then exactly where those raw materials have come from and the percentage of the ration that those raw materials make up. So for example, we know that the basis for poultry diets tends to be cereals and oil seeds or a protein crop like soya. But what we need to know is what percentage of the diet is soya, what percentage is wheat or barley or maize or oats, for example. And then for each of those raw materials, and often there is more than one origin per raw material, what percentage inclusion is the diet comprised of. Now, we have a good relationship with many of the feed manufacturers across the country and further afield, and operate under non-disclosure agreements that we treat very, very seriously. This is very sensitive commercial information for many feed mills. But alternatively, if we can't access that information, or rather you can't access that information from your feed manufacturer, and they're not happy to share it with us, then there are other methods, which is the feed manufacturer themselves can provide their own emissions calculations to you. So I'd say 5 years or so ago, feed manufacturers would willingly offer the raw material composition, and we've run calculations. Today, more and more have got equivalent software and equivalent mechanisms to be able to provide an emissions factor, essentially a carbon footprint for their diet from the mill gate. So again, further evidence that this sort of science, this sort of measurement is becoming just part and parcel of everyday business. So how do we collect the data? Well, we've got two options. We've got our EggSense customers and Avisense customers, but then we have an awful lot of footprinting being conducted with people who are not using our day-to-day farm data capture. So in case you are a recipient of a request for an EggBase carbon calculator or calculation, I'm going to explain sort of two key methods, and it depends on whether or not you are the client of EggBase, or it depends whether your customer, i.e. the packer or the integrator, are the client. Option number one, if you're a direct client of EggBase, then you'll have a conversation most likely with me or one of my colleagues, and we'll send you an Excel spreadsheet with all of the questions, 50 or so questions that we'll ask you to complete, and we'll support you if anything doesn't make sense. You'll provide us with the information. We'll validate that information by kind of triangulating it against values that we know to be true. If you give us all of the data that we need, then we compare each piece of information with another to see that they make sense and that they're logical and they hang together. We'll then complete our calculation and provide you with a 2-page report, and I'll show you an example of that in a moment. The other method is via a packer or an integrator, who themselves will then conduct that data collection before sending us a list of several farms all in one go. Once we've received that data, there is still direct conversation with the team at EggBase, because it almost in every occasion there is a degree of support or the part of the validation process to just question some of the information that has been provided. And at no point is it supposed to sound as though we are applying undue scrutiny or challenging a farmer, challenging a client based on the accuracy of their data. It's about trying to get to the best possible outcome, the most accurate estimate, and it is ultimately an estimate of carbon dioxide equivalent emissions per kilogram of egg or per kilogram of live weight produced. But it depends on the quality of the information coming in to give the most accurate data. So we work really hard to try to support our clients, whether it's the individual farm or the packer and the integrator, to really button down as much information as we possibly can. Where we've got users of EggSense obtaining a carbon footprint, then it's greatly simplified, because as Linda explained, activity data or primary data is what we do as part of the EggSense and AviSense platform in terms of capturing that daily information, either from sensors or other technology in the shed, or from farmer data entry through our app or website. So much of that production data forms the basis for the carbon calculation, and having a subscription dramatically streamlines the information required. There's still other information that does require a spreadsheet and a two-way conversation, but more than 80% of the information can be captured via the system. So having conducted the report and it's landed back in your inbox and on your email system, what does it tell you? Well, firstly, this is what our report looks like. It's a 2-page report. On the left-hand side, a page full of numbers to 6 decimal places with lots of different rows, and I'm going to go through a lot of that in some detail in a minute. It's formatted like that for a reason. And that is about compliance with the GHG protocol, reporting segregated scopes 1, 2, and 3. So scope 1 being the direct emissions from activity on your farm. So that could be combustion of fuels or manure. Scope 2, the indirect emissions associated with power supply or heat supply to your farm. And then scope 3, the upstream and downstream emissions of goods or services, or goods principally, coming onto your farm from an external source. So let's have a bit of a deep dive into the report. I hope my slide works for me here. We've got a few animations. So the first thing to look for is the total emissions over the entire period, over the life cycle. So your life cycle might be 35 days. It could be 100 weeks, as we've already said, depending on the species and on the breed. In order to be able to compare like with like, we annualize, and that's again a requirement of that greenhouse gas protocol I mentioned earlier. It allows different farms with different life cycles to come down to a common denominator and be able to judge relative efficiency in carbon emissions. That's then broken down, or the entire emission sources are broken down by percentage, so you can see where the main drivers of emissions lie. Those emissions are then expressed as an intensity ratio or an emissions factor. Fundamentally, it's it's your emissions divided by your output. So for every kilogram of carbon that your farm emits, how many kilograms of, let's start again. For every kilogram of egg or kilogram of live weight, how many kilograms of carbon that your farm has emitted, expressed both on an annual basis and over the entire life cycle. I've mentioned scope 1, 2, and 3, and all of those emissions are broken out separately in our report. And then we make an estimate on sequestration for any birds that have got access to range. So again, that's just the pasture or the trees, the green capital that are within the area that the birds have got access to. But that allows us to make a net estimate, and we express that in total tons. So we've got lots and lots of different measures on the page. The second page is a very, very straightforward breakdown in a pie chart as to where those emissions lie, and we're going to come on and talk about that massive great green proportion in a moment, which is feed. So how can I reduce my emissions? The answer, or the first answer to look at, is feed. I'm going to qualify that in a moment, because although feed makes up often much more than 80% of the total emissions on the farm, it isn't the only thing to look at. But before I do move away from feed, be aware that feed is comprised of a number of different elements, some of which are perhaps within our control and some of those which are not. So you can see on this pie chart example I've shown here that feed, again, the green, 3/4 at the bottom of the chart, is split between two different sections: land use change, and then the process-based emissions associated with growing, the logistics, and the manufacturing. Land use change. What is land use change? Land use change it's almost, think of it as a penalty that is attached to certain raw materials from certain countries of origin. So in our world, in poultry production, principally we're referring to raw materials that originate from South America, Argentina and Brazil. And those two countries where there's been deforestation or conversion of wild land into arable combinable crops, the exports from those countries carry an additional emission value associated with the trees and the natural capital that has been lost. And that's an incredibly significant proportion of the overall emissions. I'll tell you that by comparison, South American soy will have a carbon footprint that is some 10 times higher than North American soy, simply because of the attributing of the lack of sequestration of the trees that have been lost. The other thing to note on feed is that there is a vast range between low density or low emitting diets and high emitting diets. The detail of this chart is immaterial, but understand that there could be as much as a 300% range between the top and the bottom. A general rule of thumb is that the higher the protein level, the higher the emissions, but again, that depends on the country of origin. And land use change in South America are two areas that have a huge influence on not only the emissions of feed, but because feed is such a significant part of the overall result, then they have a huge bearing on that as well. So what else could we look at? If feed is, I would say, almost a corporate level concern, because there'll be a lot of farms out there who don't really get a say as to where the soy in their ration was sourced from, or where the other raw materials, the fats and the oils and the cereals were procured. Some may be producing their own, but in the vast majority of cases, you're delivered a compound ration without a huge amount of information and even less say so as to how it's being put together. So I would describe feed as being a corporate issue. I think changes in terms of long-term mitigations of emissions associated with feed come down to corporate purchasing decisions and the necessary traceability to make sure that those decisions have been carried through. But what we can look at a farm level, and again, this is repeating what Jonathan and Linda have told you already, is measures that help you improve your efficiency. Measures like how long is your life cycle. If you're producing eggs from laying hens, if you can keep your birds longer, then the embedded emissions that arrive with your pullet are spread over a greater output, and you're going to reduce your carbon footprint. If you can use feed more efficiently, reduce wastage, and improve your flock health such that you've got more eggs per bird, even over the same life cycle, then again, even if your emissions, particularly from feed, remain the same, then you're dividing those emissions over a greater size of output, and your carbon footprint, expressed as a measure of how many kilos of carbon per kilo of product, is going to improve because you are going to be more efficient. And that's good for business as well as it being good for the environment. You may have expected me to say tree planting or solar panels, and these two things certainly can play a part, but they are, by comparison to feed and the efficiency with which you use your feed, very much a small part. And in the case of trees, be aware that tree planting today does not offset emissions tomorrow. In fact, there is quite a long lead time. I don't know if you can make it out on the chart, but it's not until the trees are some sort of 15, nearly 20 years of age that they start to really hit their straps in terms of sequestration, absorption of carbon dioxide. So absolutely, it's the right thing to do to go and plant trees, but it's just not going to change your carbon footprint tomorrow. Before we move into general Q&A, I'm going to try and head off at the pass a few things that I hear an awful lot from customers of ours. So the first thing people say to me is, well, what if I don't have the information that you're looking for? What can I do? I think that you have to understand that there are some absolute fundamentals that without which a carbon footprint just cannot be conducted. If you don't know your level of production, if you don't know your feed quantity, then we're really going to struggle. But there are other things that we can have through direct conversation and detailed conversation. We can start to make some reasoned estimates about your electricity usage, for example. If you can explain your farming techniques or the system, housing system, multi-tier, or flat deck, or your electrical equipment installation in the shed, then we've done so many footprints, we can start to unpick what we think would be a reasonable estimate for your electricity. So it depends on the set of data. There are fundamentals, but there's also a conversation to be had if you simply cannot access your information. Next one, is it a cost of production investigation by stealth? I told you at the beginning that my background is the egg supply chain. I'm going to tell you black and white, this is not a cost of production investigation by stealth. The people that are asking for you to conduct a carbon footprint are doing so because they themselves have responsibilities to customers downstream or to lenders, and you yourselves as farmers will find this in due course. And the same people that are asking you to complete a carbon footprint already know well enough what the cost of production is, and they don't need to go through these hoops in order to find out. So, yeah, emphatically, I do not believe that there is any interest in trying to unpick what it costs you to produce a dozen eggs or a broiler by way of asking you for a carbon footprint. I mentioned earlier about cost information, and you should be aware that the vast majority of the calculations, certainly those that are performed by EggBase, are based on what's called process-based calculations, i.e. there have been assessments nationally and relevant reference tables for the emissions associated with a certain activity, and those databases may be government provided, or they may be privately provided. But for certain activities, there's no such thing. And within the greenhouse gas protocol, the alternative when we lack activity data or primary data is a perfectly legitimate economic equivalent. So for things like, as I mentioned earlier, medication or chemical usage, we still rely on that. And I'm sure in time, alternative process-based factors will be published, but until they are, then that's why we asked for cost information. It makes up a very, very small amount of the end result. Is there such a thing as a good or a bad result? Yes and no. As far as I'm concerned, I don't think it's going to be on the near horizon that people are in jeopardy of some sort of contractual change for having a high or a low carbon footprint. But I will come back to that. The good or the bad relates to the quality of the information. A bad result is a footprint that's based on inaccurate information. And so my plea to you listening today is please do everything you can to provide the most accurate information, and you will then have a meaningful, i.e. a good result. Irrespective of what the bottom line is, you've got something to work from, you've got a baseline. But if you don't put good quality information into it, the report is going to be meaningless. So I'd say that is the definition of a bad result. But will there be financial incentives in the future? Will there be schemes where producers can sell carbon credits or can offset things? Very, very hard to look into the looking glass and predict the future, but I would certainly say that financial institutions will be using farm measures or farm participation in schemes like carbon footprinting to determine whether or not they are a likely candidate for a favourable rate or even a lend at all. I think the onus is on business to work with responsible business, and I think that ought to be incentive enough to keep on top of it. Whatever happens in the market thereafter, time will tell. There are already low carbon and carbon neutral products on the shelf, and the farmers producing those undoubtedly will be receiving a premium, but they're a very, very small part of the market as we stand. So I thought I would just put those 5 questions out to stimulate discussion. That's quite enough from me. Sorry for overrunning. If anyone ever wants to hear more about EggBase, I'd love to hear from you directly. Please do get in touch. But for the moment, I will stop sharing my screen and hand back to Rebecca.
Thank you so much, Tom. I think that is just alleviates a lot of questions probably around what data is required, and possibly some fears when people start asking these questions, that you don't need to be fearful. I suppose just in terms of Q&A, a lot of them has been answered with those questions, but I'm not sure who wants to answer this one. But I'll throw it at the 3 of you and see who wants to take it. Regarding maximising efficiency of our systems, broiler growers are generally reduced in stock and density due to fears of breaching stock and weights per metre squared at slaughter. But surely maximising shed capacities should take precedence if we are to reach our emission targets. It's not possible to do both.
Who would you like to throw the question to, Rebecca?
Well, I'm leaving it open to the 3 speakers. I'll not target Brendan, considering he's not a broiler producer. But
shall I dive in? I never want to hold back. Yeah, well, the question is absolutely spot on, but it's it's got to be a market decision as to which way we go. But you can't be more extensive and more efficient at the same time. There is a absolute tension between stocking density and the efficient use of resources, and the market direction to reduce density on welfare welfare grounds. They are to an extent opposed. That the kind of the middle ground, the mitigation, is that if healthier animals living in lower stocking density environments ultimately end up consuming less of those resources, whether that's feed or energy, and that's a massive if, by the way, massive if, then that could have a positive impact on emissions. But I fear that is not the case, and lower density means higher emissions, means higher cost, and it needs to be paid for.
Yeah, and
Yeah.
just to come in on top of that, maybe just Tom, and I think it's important to communicate that greenhouse gas emissions or carbon footprint, it's only one piece of the puzzle in terms of the bigger picture. And like what Tom was talking about, we really need a balance across what is actually wanted from the sector in terms of animal welfare, in terms of everything else. So we just going off carbon footprint can actually lead you to a somewhat skewed place. So you do need to have a rounded view, I would believe. So, yeah.
Yeah, I'd have to agree. It's not always that welfare and sustainability will go hand in hand, but as you say, Jonathan, we have to meet what the consumer or the customer wants.
Yeah, and that's what drives. Yeah.
Exactly. I'm just conscious of time. Brendan, have you any questions you want to ask? Any other?
Yeah, just maybe one quick question, maybe to anybody as well. Tom, you spoke there about the feed making up such a high level of emissions, and that would be one thing we could reduce. Now we know there's EU legislation coming in shortly with the EUDR with the deforestation. When you've maxed out, when you've set your carbon footprint and you wish to reduce it, and if you've done all you can on your feed and on the other things you mentioned, tree planting, what other things are going to be available to you to offset that carbon in the future, I suppose, is what I'm looking for. If you've ticked all them boxes, yet you have to lower that figure even more, what other actions can be taken to bring that figure down?
I would try to alleviate any concern that farmers have that says, while they still are a net emitter of carbon, that there is some requirement to offset to reach zero. I think that's I don't see that as possible. You can't make something out of nothing. Ultimately, we have. I think the science will continue to develop, and the land itself will be a carbon sink that we don't adequately account for, and may change the whole balance of the emissions that we ultimately report. But once you've produced your electricity or whatever other energy that you're using on site, directly, once you've optimized your life cycle and your feed conversion, once you've optimized your raw material sourcing, and you're still emitting, let's say for argument's sake, a kilo per kilo, there's little else that you're going to be able to do.
Yes, yeah.
But
what in the end, sorry, would be the end goal for this recording? These figures will be in place and they will be there going into the future, and they'll give a measurement of every farm. What's the final goal of all this, I suppose?
Well, I don't know if Jonathan wants to come in on this, but the national inventory is part and parcel of this. It's about each nation. We think about where carbon footprinting has started from a corporate level. This is a top-down kind of push that started before the Paris agreements in 10 years or so ago, as international governments have committed to decarbonisation over the course of what was then 35 years or so, and this is each individual country now trying to account for their own emissions, understand their own emissions, and then the direction will be set by governments in the future, I would suspect. But this isn't, I don't think this is a farm by farm, one by one, direct path to net zero. This is a collective, aggregated position that not just each individual country, but the whole world needs to understand.
Yeah.
I would like to apologize that my internet was quite unstable a while back, so that's why I was let off.
That's
Okay.
okay, Linda.
If I could just step in there, I would just address something that you're saying there. I think what's important is giving meaning to these numbers. Okay, and really what you need to know is, so how is your system performing relative to a certain benchmark, or whether it be an average or within a certain cohort, and that gives you meaning then, because then that can also inform you of right, is what is that cohort doing that maybe my system isn't doing, that I could nearly address. So it's that kind of learning off each other is what I think what could be achieved from this as well, and improving not just greenhouse gas emissions, but also just the efficiency of the system. And just reiterate what Tom said, it's greenhouse gases, but I also think it's something that we need to be conscious of as well as the ammonia emissions and the ammonia inventory. And I don't think we can look at one without the other. Two of them are kind of interlinked with one another. So, ideally both should be going in the one direction as well.
Yeah, perfect. I think it's a tricky subject in terms of where the end goal is, but certainly I think that the key thing is to start. We have to start measuring to be able to get to that point where we're worried about how far we need to go. I certainly think both AgNav and EggBase are two platforms can help us with that. So I suppose I'd like to just finish up. I'm conscious that we ran a little bit over. I want to thank Tom, Jonathan, Linda, and Brendan for joining us this evening, and to all our producers who are online and sent in questions. I really do appreciate your time, and I hope you found this helpful. If there's any further questions after this evening, feel free to pop them across to me by email or text, and I'll put them to Jonathan, Tom, and Linda afterwards. So thanks everyone, and we'll chat to you all soon.
Thanking you guys.
Thank you.
Thanks, Bye.